Hello and welcome to episode 2 of 7 Wrangling. In this episode we'll be covering what am I doing this for, and also actually starting on the build process. So a probably good thing to ask is why is there a green tent next to me? We'll cover off that a little bit later on. Why am I doing this project and what is success? This was a really important thing for me to establish early on. Otherwise you're just really spending a lot of money and a lot of effort for no specific outcome. When I look at how I'm going to get highest miles per mile, it's going to be a cost-effective, attractive, reliable and competitive car when I eventually get it on the track. To be able to do that, it's going to need a really balanced, stiff, tunable chassis targeting under 600 kilograms, which was a key reason why I chose the MK chassis to start with. It's going to have to be reliable and turnkey. That's turn the key every single time, sort of Toyota Camry sort of levels of reliability. There's no fun in turning up to an event or planning on going out on that lovely Sunday morning drive, only to hit the starter and nothing, or the dreaded click. So it's got to be super reliable. That means choosing the way that it's tuned performance-wise, like level of performance that's extracted from the engine, so that you maintain high reliability. Eventually, with the engine, I want to tune it to about 200 horsepower and about 220 newton meters of torque. As we saw with the MK Sprint 185 that they built, they put individual throttle bodies on that and an exhaust and an aftermarket ECU, and unlocked it, to I think it was 204 horsepower. On the Dido run. I forget which episode, but I'm sure you'll find it there somewhere. So that, and through other forums that I've been reading, 200 horsepower out of one of these MZR engines is very, very achievable without needing to go anywhere near camshafts or opening the insides up, and that's me 100%. I really don't want to be doing anything internal to the engine. In terms of acceleration, ultimately I'm targeting sub 5 second 0 to 100 times, or 62.5 miles per hour for those of you in the States or the UK. That level of performance, that's really solid acceleration. And if we can get to a top speed of maybe 200 kilometers an hour, that'd be great as well. I don't expect to be seeing that sort of speed very often at all. Doesn't really need to go much faster than that, and really, how brave would I need to be to do that sort of speed in something like this? Watching the MK videos with the Cup 200 cars around circuits like Donington, that that looks pretty much on the edge to me. So as I go through this project, there's sort of 6 different phases that I've planned out, 6 R's. So the first one is received, and we can tick that one off because it turned up. So awesome. The second one is assembled. Whilst that doesn't start with an R, I couldn't find a synonym for R, so we've gone with it as just assembled. That means we've got it built, ready to do all of the testing, pre-registration. The third one is actually getting it registered here to drive in Queensland, so I can drive it on the road as an everyday car. The fourth one is getting it super reliable. So that means, getting back to what we were talking about earlier, you hit the key and it just starts and it runs and it doesn't get hot. There's no niggling issues. It just behaves, as well as the car that all the bits came from, the NC or NB MX-5. It just works. When we get into 5, and that's where we start to tune the chassis a little bit more, and maybe some tuning of the engine, well, we get it to be race worthy. That's where I can turn up to events on the weekend at the local tracks, and I can enter the car and know that it's not going to disgrace itself or me. And then the 6th step is really when we get to race competitive, which is down the track once I've tuned the chassis and the engine, and we've got ourselves an MK RX-5 that really acquits itself very nicely on the track. I can turn up in it. I don't really need to do too much to it. Check tyre pressures, race it, and then drive it home that day. In the future, I'd like the opportunity to be able to run ABS brakes with this car, so that meant running a brake line to every single corner. So the standard MK build, they run one line to the front and they run one line to the rear. So it turned out that it's, well, so far so good. I don't have any panels on the outside yet, but I think we should be pretty right. It was a bit fiddly fitting them in. This block you see here is where I plan each of the lines from each corner come to here. This block here is the removable part, along with the line that goes to each master cylinder and will be replaced with blocks that then enable these lines to go straight up to the ABS pump, which will sit on top. So here you can see the brakes set up with the future ABS system that's come from the donor car that I'll install at some point in the future for motorsport use. And I'll run the lines from down the bottom here. These two blocks get removed, and each of the 4 lines that come from the 4 wheels will then be plumbed straight up into this ABS pump here. So the brake lines in the front, I was able to run nicely along the outside and then up to each wheel, as you can see there for the front right, and then similarly for the front left. Down the transmission tunnel in the normal way, nice and low on the right hand side. We can also see the fuel lines. As I said earlier, I've chosen to run a return line, not necessarily for getting fuel back to the tank, but so that I can get fuel vapour from the tank and burn it in the engine as part of the emission system. And here's a view looking at the brake lines as they exit the rear of the transmission tunnel, duck underneath the disc housing along that rear lower chassis member on the right hand side before they then turn and go off to the right hand wheel and left hand wheel respectively. Now all of the brake lines and fuel lines, I ended up 3D printing my own mounts for those. They're those little black things that you see just out of ASA, and that's a stainless steel M5 socketed cap screw through the centre, and I just drilled a pilot hole in the chassis, I think it was 4.2 millimeters, and tapped that to M5. And it worked out really well, because to get these the way that I wanted to, I needed to put them on, take them off multiple times. Job number 2, once the brake and fuel lines are in, was to install the floor panels on the basis that you want to do that when you've got the least amount of stuff attached to the chassis, so it's the easiest to turn upside down, because you can only do it upside down. I did the 2 floor panels and the rear firewall in the first sitting. The other ones that I'll get to later on, which consist of the 2 transmission side panels, the transmission top panels, and the front firewall panel that fit on. I'll deal with those later on, because I want to maintain access to key components for as long as I can. So with the floor panels, I went a different way than the standard MK build. Given the testing on the chassis that I did in episode 7, I decided that I would epoxy bond the floor panels into the chassis and use stainless steel rivets. One main reason for that is that the floor area on this MK chassis, there's no diagonal bracing on either side between the front and rear firewalls. There is a little bit behind it, and obviously there is some in front of it, but nothing in that void. Now, I've subsequently increased the stiffness of the transmission tunnel on the top and the bottom, so I've got sufficient stiffness built into the chassis there. But I wanted to see what would happen if I epoxy bonded the floor panels in. So the standard MK build uses like a polyurethane material, which is flexible, and they use aluminium rivets. That does a fantastic job for dampening out vibration that you're going to see in this chassis, because of the things that are bolted to it. Whilst I've made a compromise there by using the epoxy, which dries absolutely rock hard and gives a very stiff bond combined with the stainless steel rivets, I know that I'm going to have some vibration issues that I'm going to have to deal with some other materials, but I know that I've been able to then use the floor panels as a properly integrated stressed member into the chassis. The reason I use the stainless steel rivets, well, aluminium's not that great in shear, stainless steel is a lot better. But with that came definitely using a pneumatic pop riveting gun. Whilst I was able to get 1 or 2 off with the hand pop riveter, there's no way I would have got them all done in that one sitting whilst I had the epoxy going off. The epoxy material I used was Sika Power 4720, which I think is they class it as an OEM grade epoxy panel bond material. It is eye-wateringly expensive. It was about $130 for a standard sized caulking gun tube. The kicker is that you only get to use about 2/3 of that caulking gun tube, and it just stops. So obviously there's all of the mixing stuff inside there that's taking up about 1/3 of it. So that was a rude shock when I got to the end and realised that I was missing about probably 5% of what I would have liked. But anyway, I was able to borrow some from some other places and get all of that installed. Now the rear firewall, as I mentioned earlier, I did choose just to go with the standard polyurethane adhesive on that, and also use stainless steel rivets again. The reason I wasn't so concerned about the rear firewall and using the epoxy on that is because it already does have bracing in there. So I didn't really think that it was going to make a great deal of difference by bonding that in. And also the majority of the tubes running around on the inside of that rear firewall area, they're all round anyway, so I wasn't going to get a great deal of contact area to bond between the chassis and the back of the panel. So that's just gone in the standard way. The only deviation is I've used stainless steel 4mm rivets rather than the aluminium ones that are standard with the MK build. And with the other panels, I'm planning on just doing the same thing, sticking with the stainless steel rivets, but just using the polyurethane to glue them on. I'll probably, on top of the transmission tunnel and also over the front firewall, I think I'm going to go fairly light with the polyurethane glue, just so that I know I can get them off in the future if I need to for access for some reason, without needing to destroy the panel in the process. And I'll probably use those M5 socketed cap screws as well to hold them down. When I installed the rear panel, I did actually add some 25 to 25 by I think 1.5mm aluminium angle to the sides of those the side members, just so that I could support the rear panel with some extra pop rivets. So with the brake and fuel lines in, the floor panel's done and the rear panel done, next step is to install the engine and gearbox and suspension. So that actually brings me back to the tent. So this is the engine that we'll be using in the build. It came from a 2006 NC MX5 with about 78,000 kilometres on it. It looked nothing like this when I got it, and it took me about 5 hours to clean it all up and then paint it, hence the tent. I needed a way of being able to paint it indoors without getting overspray everywhere. So my mate came up with a great idea. Why don't you just buy a tent and do it inside that? So thumbs up for the tent, because it worked really, really well. Don't recommend spending too much time in there with it though. That's the only thing. Anyway, that's it for this episode. Next time we'll get the engine in, we'll get the suspension fitted, and we'll get the fuel tank in as well, and possibly a few other bits and pieces, I'm sure. So join us then. Thanks for watching.